Okay, guys, in the previous time we stopped here. We talked about the heat transfer, or the ways where the heat is transferred. Okay. Now we solve past paper questions about this topic. Just quick revision here, guys. We have 3 ways for the heat to be transferred, right? Conduction, convection, radiation. You know, guys, conduction is taking place in metals, right? Since sorry for that. Okay, guys. Conduction takes place in metals. Why? Because, guys, in metals we have what? Free electrons. These free electrons will carry this heat from one side where to another. Convection takes place where in liquids and gases. If you remember, convection takes place when you heat something like this, right? When you heat the water, the hot end here, or the water in the hot end, becomes expands as a result of the temperature. Increase, it expands. So as it expands, it has less, or it becomes less dense. So it will rise up. The cold one here, it will sink down, and so on. So as a result of that, we have these convections. Radiation takes place, guys, in vacuum. And we will focus on the effect of the color on either absorption or emission, right? Absorption or what? Emission. Okay, I will show you that. Now let's do several past paper questions. Look to this question here. Figure 5.1 shows 2 identical metal plates. The front surface of one is dull black and the front surface of the other is shiny silver. The plates are fitted with heaters that keeps the surface plate at the same temperature. State additional apparatus needed to test which surface is best emitter. Guys, as what I mentioned before, and we have to focus on that. In order to check, guys, which is best emitter and which is best absorber, I have to check the temperature. If the temperature inside more than the temperature outside, right, this is emission here, or emission is taking place. If the temperature outside is more than the temperature inside, this is what? Absorption. Since here the temperature inside, because the heater is inside the object, so temperature here inside is greater than the temperature where? Outside. So as a result of that, we have the emission. In order to check which what is additional apparatus needed to test the surface that best emitter, I need infrared detector. Infrared detector. Okay, infrared what? Detector. I have to place this detector at equal distance from each one or from each, okay, from each surface. State one precaution that is needed to ensure that the fair comparison. We have to place the infrared detector at the same distance from the heater, right? Or from the surface of the heater. State the result that you expect. The black one, or the dull black, is a better emitter than the shiny silver. Sorry, dull black. Forget to write this. Write another name for the heat radiation. It's infrared. It's what? Infrared. Archaeologists digging an ancient site discovers a spoon. The spoon is made from unidentified material. Right? We don't know what is this material. Archaeologists suspects that the spoon is made of metal. She
مرحبا أستاذ.
هلا Kinan. She places it above the flame as shown in figure. Okay, here we يعني, let's say this scientist found this spoon somewhere under the ground. He wanted to test this. He supposed that, or he suspected that it's made of metal. She places it above the flame as shown in figure. She noticed that the handle of the spoon quickly becomes very hot. State why this observation supports that the suggestion the spoon is made of metal, because metal, guys, is a good thermal conductor. Is a good thermal what? Conductor. Describe in terms of atoms how thermal energy is transferred to the metal. Here, guys, as what we mentioned before, the electrons at hot end gains kinetic energy, so they will move faster and collide with other slow electrons اللي هم بالcold end. Consequently, guys, as a result of that, the heat will transfer okay, other slow electrons. So the energy, or part of this energy, is transferred to these electrons and so on, right? During the collision. To these electrons. So heat will transfer to cold end. Okay, guys. Also, let me remind you by this, you will find all these things in this chart, guys. The explanation here, fully explanation. This is the chart here. I have to write this part here. And the question, I have to write this part. Free electrons move at high speed at the hot end. They have high kinetic energy. They collide with slow-moving electrons. So kinetic energy is transferred during this collision. As a result of that, heat will transfer. Okay. Let's go back again to the questions. Okay. Here, figure 4.1 shows a vacuum flask of cross-section of double-walled glass. Please read this question هيك بس for a second عشان تفهموا what we will ask about, what we will be asked about. Okay.
قرأت بس ما فهمت أول واحدة.
هلا اوكي هلا احنا do you remember the vacuum flask? قلنا ال vacuum flask it's manufactured in certain way, okay, in certain way, so it prevent, look, listen to this, the vacuum flask will prevent the heat transferred either from outside but instead لا بلاش نقول prevent, will reduce the heat transferred even from outside to inside or from inside to outside. So if you place a hot liquid inside it, we want to keep it hot as much as we can. If I place cold liquid inside it, we want to make to keep it cold as much as we can or as long as we can. Okay. We want to reduce any heat transfer. We want to reduce any heat transferred. So what are the properties here? We have, do you remember, here we have air gap. Here we have a vacuum between the double wall glass, right? It's painted silver. Where is the point to prevent conduction? Right, to prevent what? A conduction. Conduction means to prevent conduct or to prevent or to reduce the conduction. This means I have to prevent or I have to use insulator. صح كده؟ I have to use what? Insulator. On وين الانسوليتر؟ وين الانسوليتر هون؟ هيا اللي هي الاير جاب او الفاكيوم، هذا الانسوليتر. اوكي كنان؟ هلا هذا الفاكيوم
اوكي
او inside or in this cavity between these two double wall glass no molecules for the heat to be transferred, right? No molecules for the heat to be transferred. Okay, first vacuum is a poor conductor or poor conductor. Insulator is an insulator. So the heat will not transfer by conduction. ليش the heat will not transfer by conduction? Because no medium or molecules right? To transfer the heat. Is that clear how we write the answer? Here now, why the rate of loss of thermal energy through the walls of the flask by radiation is very low. Okay, because you know that it's coated by silver, right? With silver is a bad absorber and emitter, right? Shiny. Is that clear, Kinan? Shiny silver
Yes.
surface of the wall is a good reflector, good thermal reflector, or thermal radiation reflector. Bad emitter and bad absorber. So no heat or no thermal energy is being أو less sorry مش نقول no لأنه less heat is being absorbed from surrounding or emitted from the liquid. Okay, clear? Here, one side of copper sheet is highly polished and the other side is painted matte black. The copper sheet is very hot and placed in a vertical position as shown. A student places her hands at equal distance. Okay. From the sheet as shown in figure 5.1, explain why her hands are not heated by convection. Guys, convection here, hot air, here there is a hot air, here more hotter, صح? Let's consider this. Hot air, as a result of convection, rises up, right? Because the convection is taking place vertically, guys. Convection is taking place what? Vertically. And warm air rises up. Cold air what? Sinks down. As a result of that, hot air will not reach what? Will not reach her hands. Okay? Warm air rises up. So it will not reach her hands. Okay? By conduction, you guys, the air inside here, the air between, this is air, right? Air is a poor conductor, is a poor thermal conductor. Air is a poor thermal conductor. So it does not conduct the heat, right? It does not conduct the heat by conduction. By conduction. Clear? State and explain which hand gets hotter. The hand that will get hotter, the left hand. Here, guys, to the hand or to her hands, guys. The heat will transfer to her hands by radiation. which one will emit more radiation? The black one emits, right, more thermal radiation because it's a matte black, which is a good emitter. Here we consider it as emitter. Right? We consider it as an emitter because larger than the temperature or the outside temperature. So here the left hand, because the matte black is a better thermal emitter than it's shiny silver or polished side, صح? So more heat, so more heat will reach air left hand. Okay, guys? Any question about that? Here it's suggested that one side of the copper sheet cools to a lower temperature than the other side. Yani this is a kind of prediction. Explain why this does not happen. ليش هذا الاشي مش ما صار او يعني you got my point. يعني احنا we expected او one of the common mistakes ان the student may think انه the hot one here, the hot side is the black side is hotter than the polished side since it's black. Okay, تمام كنان. Let's say انه هذا let's say انه it's a common mistake. Let me magnify this. This is the matte black side, sorry. This is a polished one. Accordingly, guys, since they are in contact with each other, and let's say initially the matte one has higher temperature, and here temperature here is higher than temperature here. Yani if I get this is as a black, this is as a polished one. Initially, pay attention. Initially, let's say in the black more than what? The polished one. Since they are in contact with each other, the heat will transfer from, since they are metal, the heat will transfer from hotter region to colder region until they reach the same temperature. If they reach the same temperature, it's called thermal equilibrium. Thermal what? Equilibrium. So eventually they have the same temperature. Okay, Kinan? Any question about that?
No.
يعني خلينا نقول هيك initially yes they might be or they may have different temperature. They may have different temperature. The students always thought like this or think like this. Sorry, things like this. No, the hotter one will have a higher temperature than the black one will have higher temperature than the polished one. This might be true for at initial moment, but eventually, since they are conductors, they are in contact with each other. The thermal energy will be transferred from higher region or from a hotter region to colder region until they have the same temperature. So eventually they have the same temperature. Okay. Uh, this is why this does not happen. They have the same temperature because heat will transfer from the hotter side to the colder side until they reach thermal equilibrium. Uh, yes, because copper is a metal, so it conducts heat. It conducts what? Heat. Okay. Here in space below, draw label diagram of every time situation in which convection currents takes place. Make path of the current with line and so on. Yani here we have several ways, several things. You may about cooking something like this. Here you may draw like this. Here heat or heater or whatever. Bunsen burner, whatever. Here water, right? The hot water rises up. With cold water, what? Sinks down and so on. Okay, label the path of the current or direction with arrows. Any question? Okay, here this is an important question. Figure 5.1 shows X-ray tube. You have to read the question carefully. In the production of X-ray, the, the target gets very hot. Okay, the target gets what? Very hot. So طب خليك والله معي شوي كمان. معنا كنان. بس كان لازم اجيب شوية اشياء.
هنا موجود.
طيب حبيبي اوكي نكمل. شو عملت انا يا الله. طيب هلا here we have X-ray right like this. This is the target. Okay, this is what the target. هلا no matter how the X-ray will be produced, this is not our topic, or it's not our or it's not in our syllabus, sorry. But the main point, the target gets hotter as a result of that. Thermal energy must be removed from the target. We have to remove this thermal energy. The tube has several design to remove. Yani this is what we have to focus on. We don't care about the production of X-ray. For each of the following types of energy transfer, describe how the design of the tube increases the rate of heat transfer. State where the thermal energy transfer mostly happens, and the particular design feature that increase the rate of transfer, and a brief explanation. Guys, this becomes hotter. So we need to transfer this energy outside. You got my point? This is a hotter one. We need to transfer this energy outside the target. Here we have several ways to transfer this energy: conduction, convection, and radiation. Conduction. Where conduction can take place? Look to the design. Where can conduction take place? Sorry. What is this? This is copper rod, right? So the heat will transfer from hot region where? To cold region by conduction. Right? The heat should be transferred from hotter region where to colder region relatively through the copper rod, because the copper rod is a thermal conductor. Where in the rod, or in the copper rod, right? This here, or a thermal conduction is taking place in the copper rod. A design feature, it's made of metal, copper. Explanation: metals are good thermal conductors. Okay, guys? Now convection. Convection means what? Means the heat here will be transferred vertically up. This is the convection, right? And the hot, warm air here. Warm air here, guys, near the fence, near these fence. Warm air will rise up. طبعا this air becomes warm because it absorbs, let's use another word, because it gains heat from where? From the copper rod, because copper rod becomes hot. So warm air here near to the fence or metal fence get warmer because it gains heat from the fence or from the rod. So where it takes place, okay, between the fence, a design feature, its fence, or why why the end of the copper rod here made of fence like this. Because guys, here the fans will make more air in contact with what? With the metal. يعني if I compare, if I make it solid like this, if I make it fence, if you manufacture it as a fence, here guys, only the air here will be in contact with what? With the hot region. Here, look to this amount of air that will be in contact with a hot copper rod. So basically here guys, by making them fence, or by manufacturing the end of the tube as a fence, we will increase the surface area that the air are in contact, or is in contact, sorry, with the hot metal. So it will gain more heat from this metal, and the rod becomes colder. Okay, or the copper rod becomes colder. So fence here, so more surface area. For the air to be in contact with the hot copper rod. So more heat is gained from the copper. Therefore, it cools down. Okay. Hello, radiation, guys. Radiation here. The end of the tube is made, right? The end of the tube is made, or is painted, sorry, is painted black. Why? Because it will be a better emitter. So if it emits more heat, the copper rod becomes colder. يعني where here radiation at the end of the copper rod, a design painted black. Why? Because black is a good absorber. Okay. Any question about that? Okay. Here, the water in a copper hot water tank is heated during the night. During the day, the water cools as thermal energy heat passes from water to air surrounding what? The tank. Okay, water to air that's surrounding the water tank. Now describe the process by which, right, by which the thermal energy is transferred, right? Okay. By طبعا conduction here. We have إيش? Conduction. If you طيب هلا first of all water, or let me draw this to show you this. Okay. To magnify the walls of the water tank, right? The metal. And here we have a water. This is what? metal. You know that the water molecules, guys, are moving somehow random, not like high. Here there are metals, right? Atoms, right? Metals what? Atoms and so on. هلا الهوت water, guys, how the heat will be transferred. الهوت water molecules will collide with what? With the metal atoms, okay? The hot water molecules will collide with the metal atoms. As a result of this collision, what will happen here? They lose some of their kinetic energy, right? And the metal atoms will gain this kinetic energy and they vibrate what? Faster. They vibrate what? Faster. So as they vibrate faster, the neighboring atoms also will vibrate faster as well. So here also we have air molecules. And here the green ones are air molecules, right? When these air molecules, guys, collide with metal atoms that are vibrating faster as a result of this heat transfer, the air molecules will gain energy from where? From these atoms. As a result of that, the temperature here in water decreases, the temperature of the metal wall or metal walls decreases, will air temperature increases. فالheat transfer in this way. Clear? Guys, this is the way that the heat is transferred from hot water to air outside. Any question? Before writing, any question? Okay. So here, first of all, I have to mention that, you know, if the temperature is high, if the temperature of water is high, so the kinetic energy of water molecules is high, so they will collide with metal atoms. As a result of that, the heat will be transferred from water molecules where to the metal atoms. As well, this will take place also from metal atoms where to air molecules, right? To air molecules. Any question? Let me write this. Water molecules have high kinetic energy so they collide with the atoms of the copper tank so the energy, or there is an energy transferred to these atoms which causes them to vibrate faster. So their neighbors, or therefore their neighbors, vibrate faster as well. right? Okay, so the heat will transfer to outside. Okay. Here state why the rate of which thermal energy passes into the air decreases as water temperature falls. هذا الريت اوف حكينا عنه الريت اوف heat transfer by conduction depends على temperature difference, right? Depends على temperature difference. يعني هون بيكون عندنا less kinetic energy, right? Less kinetic energy. As the temperature difference is less. Okay. So بصير عندنا ايش less transfer او less rate of transfer. Less rate of transfer. Okay. خلصت. طيب we will complete next time. طيب. Stop here. I will answer this question. Let me check if grade 11.
أستاذ هلا مسلونة بعثت لي إنه أسألك متى بتخلص حصتنا، لأنه هي هلا قبل شوي بعثت لي إنه بدها تعطينا حصة اليوم.
مس رنا؟
مس لونا.
طيب عندكم حصة بعد هاي. طيب خلص اوكي ماشي.
خلاص تمام.
Okay, we can stop here. كمل إن شاء الله next time.
إن شاء الله. شكرا أستاذ.
Okay.